in the course. But hopefully what you did in grade 11 will help you with this idea here. And this is one of the ideas, is the reference angle. I'm not sure how much you remember from your work with trig in grade 11, but you hopefully found that if you took an angle like 30 degrees here, and you put it on your calculator and you went sine of 30 degrees. And we're not going to get to doing trig ratios for a while here, but you might have found that sine of 30 degrees was 0.5. But there's some other angles that are all related to that angle in the other quadrants. If you draw them so that all these angles are the same. So that's 30 degrees, but that's, what would that be if the dots are the same there? 150, right? On your calculator, sine of 150, not just on your calculator, is the same thing. You might have found that this angle, what would that be? 210. You'd find that sine of 210 is negative 0.5. And the last one there is 330. That's the sine of that angle is negative 0.5 as well. These angles are all related to each other in that the number part, the absolute value of the trig ratio is the same. So before we get to doing, working with trig ratios, we need to be able to see the connection between all those angles. The reference angle for any angle is the little angle it makes with the x-axis. And the reason being is because all those angles have the same. The reference angle and the angle itself have the same absolute value trig ratio. Okay. This is a picture that hopefully helps you here. The quadrant numbering, quadrant 1 is this positive one up here, right? This is 2, and 3 is down there, and 4 is over there. But the reference angle in quadrant 1 is the angle itself. I'm going to use theta r, means theta reference. Hopefully, again, some of you have used subscripts in physics, right? If you're talking about some distance, I don't know, distance at 0, maybe you call it distance with an I, initial distance, or whatever letter you happen to be using, those things mean something. In sequences and series, term 1, term 2, term 3, it's just extra information about that variable. Theta r just means the reference angle for theta. For quadrant 2, the reference angle is in there. It's always with the x-axis. I wrote that up here for you, and perhaps you might want to. Smallest angle between the terminal arm and the x-axis. Reference angle is always considered to be positive. That's a good thing to notice. And maybe you want to see this here, that the reference angle is not with the y-axis, it's always with the x-axis. Quadrant 3 is the one where people make that mistake. For the relationship in each of these cases, well, actually, let's draw the other ones first. In this, you have the reference angle there. Kind of goes backwards. In this one, it's over here. The relationship in each of these cases, in quadrant 1, theta equals the reference angle. They're the same angle. In quadrant 2, theta, which is this angle, is equal to 180 degrees minus the reference angle. Right? To get theta itself, this angle down here, okay, to get this angle down here, it's 180 minus the reference angle. So you could say theta equals 180 minus theta r, or in radians, not 2 pi, what would it be? Pi minus theta r. Most of what we're gonna do is gonna be in radians, but I'll put them both down there. In quadrant 3, if you want to write it in quadrant 3, maybe that makes more sense here. Quadrant 3, this to get the relationship between these is theta is halfway around plus the reference angle in that case, right? 180 plus theta r, or pi plus theta r. And then in that last quadrant, if you want theta and how it's related, it's all the way around, so 2 pi minus So theta is 2 pi, I guess we should keep our degrees thing here first, 360 minus theta r, or 2 pi minus theta r. And that's that. I think you probably know that, or you can see that hopefully. Any questions about that? Move that up there, the right quadrant. There's not a whole lot else in this section. There's a lot of pages. Everything takes up a lot of space, but there's not tons of concepts for you to do. Mine, I don't know why the title ended up on this page, but I tried to put throughout here some little kind of practice, check your understanding things as we go, rather than in the past units I've put it as a separate booklet. So if you see this check your understanding throughout here, right, a couple different places it says that, just questions to kind of do and check and see where you are. That being said, if you want some practice, where I would steer you one place is, I don't really care what you use for practice, right? It's up to you how well you want to understand this stuff, but you could refer to the textbook if you want, if you've signed one out, and if you haven't signed one out and you want to sign one out, there's lots of them, you can sign one out. But it's not coordinated with the textbook in that the number here doesn't mean it's in section 3.2. You got to look here to see what section it's in. But it is in there, and there's some practice. Some of it's good, some of it's not so good. You can pick what you want to do. Again, just look for what concept you're working on, and you think you want to know, and do something. Check the answers. There's lots of other things you could use. Some of you maybe have bought that, what's that book? It's like a paperback sort of bound, that blue, it was blue or red on the cover. If you have that, you can use that. I'm sure the internet is a good resource. It doesn't matter to me what you use for practice. Some of you are, going to work through these, and that's going to be maybe enough, and then work on assignments that I give you. Some of you, I think, maybe do better working in part in the textbook. I don't know. It's up to you. Everybody knows what works for them.